Hey, how's it going? It's Liv. So, today I just want to quickly demonstrate a little bit of something. So, I'm working on this new parser, right? And one of the things I want to do is with this particular function, which is in the node class, we have a couple functions actually. It's one is branches in, which basically will give you every branch of the tree that starts with a given pattern, right? So the value field of a node in the tree could be considered as just a string, right? So you can assign it other kinds of values, but generally it would be a string. And so we have these functions in order to find nodes matching a given pattern. And so the first one is branches in, and it will give you, a branch that's, it starts, the root node of that branch will be something matching a given pattern. The other one we have is branches with, okay? And it's basically the same, but it doesn't look at the root, it looks at the leaves of the root, right? And so if you have a root that has a child that matches the given pattern, then it will return that branch, right? So the entire thing. And these are functions that are actually quite useful. The thing is, there is a little optimization we can do here because as it stands now, we are passing this look for variable. We are passing it, this is utilized as a regex, right? It's a regular expression. And the thing is, I'm passing it as a plain string, which is not the best way to go about it, right? So let's fix it. Okay, so the first thing we have to do, and this is like the first problem, we have to make sure that every time this function is invoked, it is these two functions are invoked, it is done so through it is done so with a compiled regex, right? So utilizing the QR modifier, okay? So it would be a problem trying to remember all the mentions of this, but luckily enough, I have tools in order to facilitate the job, okay? So I am at the top of the project hierarchy, at least for Automat, that is. And what I'm going to do is I'm going to just invoke this short program that I wrote like last week. Still experimental, but actually pretty complete as far as what it's supposed to do, okay? So we have to pass R for recursive because we want to look at the entire folder structure. We pass in the S, we pass the symbol that we are looking for, quote unquote, so a pattern that we want to match. And that would be, we start with branches in, and after that, we just pass where we want to look, and I'm passing a dot so that it will look at the current working directory and look at the entire thing because we're going recursive. So here we go. And okay, it executes almost instantly, which blows my mind. But anyhow, here we have all the mentions of where this invocation is made, together with the line number and the name of the file. So this actually simplifies the job a lot for us. Okay, so we'll start with RD. Okay, and let's just go into Bisu RD, and it was 1450. And okay, so in here I already know this cut B regular expression. This one is already compiled. I know it because I just wrote this piece of code. Okay, so cut B re. Okay, and here we go. This one is being compiled right here. So actually, this section of code I have to move it somewhere else, as it says right in here, right? But one thing at a time. Okay, so all right. So that part is done. I'm just going to select this just to mark it as done. Now let's go into node. Okay, so a Bisu node, and let's go just in order 7 and okay. All right, so it is worth it to compile to compile the expression before calling the method, right? And the reason why is actually quite simple. It's just that how can I better explain this? The thing is that we don't want to be compiling the same expression over and over again, right? So we want to compile it just once. And because these functions are always working in a loop, right? So the earlier we can compile it, the better. However, these functions are, it is expected that that this I character, which is essential in the search, would always be changing, and so we really couldn't do much if we were expecting for the caller of this method right here to compile the expression. So basically, we would have to do it at this point. At least I think so. And in any case, if it turns out I'm wrong, we can always just change it. Okay, so basically that's that. And we just want to now pass the regular expression, and that's a wrap. Okay, so same thing in here. So this is essentially the same function, except that this one returns you the entire array, and this one just well, it's half and a half the same function. This one just returns you like the first match. How can I better explain this? So it looks at every branch that has a field variable, right? And it will return you like the first field, and this one will just return you the entire structure with the field, something like that. But anyhow, so this one will give you every branch that has a field node, and this one will just return a single one, like the first match. Okay, something along those lines. Anyhow, the expression is basically the same. Yeah, it is exactly the same. And okay, so that's a wrap basically. And let's go into the next one. That's 793. Okay. All right. So apparently, yeah, same little bit of the same story here. Just a little bit of the same story. Yeah. You can just, oh, wait a minute. One thing I forgot. I actually do need to add this in here, right? So we do want to match at the beginning and end of the string. I'm not entirely sure if the interpolation will work right this way. I'm pretty sure it should. Um, it looks kind of weird. It does look really weird because of the double dollar sign. So I tell you what, we could try. We could try to make this as a string first, and then yeah, but I think it's a little bit too much. We'll see if this one works. If it doesn't work, we'll know because it will just overflow or error logs, right? So we'll know if it doesn't work. Okay. So let's compile this one as well. And yeah, this is a lot of just writing boilerplate. That's just what it is. But I mean, as far as code refactors go, this is some of the easier times I've had in a long time. So oh, right. So here's the definition, so we can skip that. And 30, 40, what? 9. So it must be right here. Okay. Okay. So in this case, we would like to how do you say? I would like to check out where this one is called, because in this case it would be the responsibility of this call right here. because it's passing in a pattern, it should ensure that that this pattern is compiled. At least I think so. Okay, so tell you what, I'll just do a little list, and first I'll just work with ut, and I want to write branches values. Okay, so we'll look at that later on. Okay. Okay, so what else? Let's mark all of this. And actually, I can do it from memory. It's not that much. Yeah, just little things. Okay, so PLPS. All right, so PLPS is a little bit of a mess right now. Well, we're gonna just adjust this this one thing, and that will do that. Okay, so 377. All right. So yeah, and I know this this subroutine is called only once. It's like a setup script, so to speak. So we can just do this. Now this would PLPS programs are typically very short, so this would be a very small gain we would get, but just to try and be consistent here, right? So that's more or less what I want to do. And in here, okay. And this one is very important that we compile it because it is happening inside of a loop. So that's, yeah. And this one is also called just once, but it's iterating through the entire hierarchy, right? So it's going through the entire hierarchy of a PLPS program. So again, PLPS programs are typically very short, but just in case we ever write a large PLPS program, yeah, we would like to not have to compile the expression every single time inside the loop, right? So yeah, because as I understand it, when you just pass it like so as a string, Perl basically doesn't know what the regular expression is every time it has to look at it, and so every time it has to look at it, it has to rebuild it basically. By doing this, we are. I guess it would be better if we mark this as a read-only, right? Because in this case we can. Well, that is true. That is true. Huh. Okay, so let me just check something real quick. I'm gonna have to Google this one out. I'm sorry, because I know a module to do it effectively, but I'm not entirely sure how it works. So let's see, Perl read-only, and let's see if we get any results that are meaningful. And actually, yeah, I said Google it out, but of course I'm using the duck. All right, so this one is gonna tell me. I just want to know the syntax, basically. Let's see if we get something. Okay. Let's see, read-only, where is it? Yes, just show me the syntax. Okay, so use read-only, and then read-only, the, how do you say? The lexical scope qualifier or something like that. I don't know how to describe, how to classify this, but basically the scoper, I'm going to call it. And okay, all right. So it's kind of like use constant, but yeah, like I enjoy the use constant, but it's, and yes, I aliased the browser as suck. You figure out why, okay? But anyhow, Okay, so let's try it. Why not? Because generally, what I would do is just use constant, and then you just pass in a name, say um, backend regular expression, and then we just declare, right? And we can just put the thing in there, right? So here we write some regular expression or whatever. But the thing with this is it's kind of hard to interpolate. Like in previous versions of Perl, you can get away with doing something like kind of like this, right? Something like this or like this. And this one still works as far as I'm concerned. But sometimes, for whichever reason, Perl, at least this version I'm using, 5.36, will identify this syntax as trying to, I don't quite remember what, but I think it interprets it as being either a hash or a declaration of a subroutine for some reason, something wacky like that. I don't quite remember. But yeah, let's just use read only and be done with it. Read only. Okay, if I can type. Okay, so which line was I? So let's revise these two. Oh, okay. It was 7.7, but not quite so early in the program. Okay. So let's say read only, and I wonder if I should just put all of these. I could say read only state now, because it's basically static that's scoped entirely to this function. It's not used anywhere else, so it would be kind of irresponsible to just have it available to the entire module, I think. And I would have to give it a more meaningful name, right? So yeah, let's try it like that. And if it doesn't work, we'll find out. If it doesn't work, we'll always find out. Anyhow, same thing here. So read-only state. Okay. Right. So that basically saves us from having to recompile the expression every single time for every single leaf, for every single branch, for every single leaf of every single branch of the entire program tree. So that might be a little bit faster. Maybe not by a lot, but what you're gonna do. Okay, so that's that for PLPS. And if I messed up here, we'll find out. And okay, let's go into the auth module. Okay, so this one is a mess. It's this one is actually one of the first. It's one of my first, if not the first, Perl module that I ever wrote. Yeah. Uh, so it's not my best, I have to admit. I'm trying to. I've been trying to update it a little, making it slightly tidier. But yeah, we're still doing the use constant and things like that. So, yeah, it's not quite so nice. And oh, I just realized I do have to do this. Like I almost forgot. No. Okay, there we go. All right. So basically, yeah, this one is also a little bit of a mess. We'll clean it up as we go. So, oh, okay, all right. So in these ones, we can make them read-only as well, because generally this will always be the same as far as I remember. Yeah, yeah, they should always be the exact same. So basically, what this is doing is reading from it's calling a PLPS program in order to pass a given expression and tell if it is a actually no, it's not telling you if it is a symbol declaration. It's breaking down a symbol declaration. For now, it's only only in use for detecting C declarations of C functions. This is what we use in order to create the the FFI bindings for C and Perl, right? So basically calling C functions from Perl without having to write an extended sum, right? Like XS, right? Which is yeah, it's not my favorite thing, honest. It really isn't. So yeah. So I'm just going to put in here type-re. That's meaningful enough. Oh no, actually this one is spec-re. Okay. So spec-re. Let me just copy this one over and type-re. I'm just gonna put them in order so I don't mess that up. Even though it wouldn't matter, because branches in will look for that specific thing. But yeah, we have like the names here, so I have to get this one right. Because basically I don't want the thing telling me the indirection level to be actually the list of names, you know. So yeah, in level re, and here the bear, which is actually names. So I could say name free, but yeah, that would be for valid names, and this is just in order to find the branch of the tree that holds these values. Okay. So all right. Let's just let's just do the same thing we did in the other module. Let's say read-only state spec-re, and that's equal to qr all of this. Not q, that's another thing. Read-only state type-re qr and all of this. And yes, I could do it like that. I could also do it like this, because this is Perl. Okay, so let me just show you real quick this, because it's kind of cool, right? You can do this in Perl. This is a string. Okay, so yeah, I know it's kind of crazy, you know. So this is hello world basically. Actually, I think I would have to. I don't think I can get new lines, so I would have to literally put a new line there, and that is a valid string declaration in Perl. Can you believe that? We could use any operator as far as I'm concerned. We could do it like this, right? So yeah, kind of crazy, but no, I like to keep it simple. If because I mean, you could do it like this as well. I tested yesterday, and yes, you can. But the thing is, this is like the common way to do it, I feel. And it's kind of the way that makes more sense, I think. I prefer to do it like this, just, you know, using the same kind of symbols for the same purpose. And the one exception I would say is, for instance, when you want to make a string out of a single parenthesis, right, or a parenthesized expression, this looks kind of weird. So in this case, yeah, you could try something more wacky, I guess, or something like this maybe. I don't know if this one will work, right, because it might get it confused with a label. I don't know. But I prefer brackets, right, square brackets. Like this, yeah, it's still a little bit hard to read, but it's not quite so bad. Okay, so enough chatter. Let's get right back into it. Okay, so int level re, and let's qr all of this, and same thing here. Okay, so read only state bear re, and it's all of this. Okay, nice. So why use state? Because state is only executed once, okay? At least as far as I'm concerned. If you say, for instance, state x equals 0, this will only be set, I think, at compile time is when it will be first set, and then whenever, say I say x plus plus, this x plus plus will be executed every time you enter the subroutine, but the the declaration or definition this will not be executed more than once, right? And so it's a static, right? It's a static variable. And so my idea here is that I only want to compile these things once, okay? And so this is, I feel, the one way to do it. It might not work. I've never tried, honest to God, I've never tried read-only using state. But I feel it should work. If it doesn't work, we'll find out. So right, okay. So yeah, we still have to look for dimensions of branches width. But what I want to do first is try and build this and see if it actually works. Okay, so let's try that. Okay, so I'm going to be doing this using auto, which is an automatically generated sort of like a makefile. It's let's say it's analogous to a makefile, right? But it works for multiple languages. For now, just Perl and C, but yeah, it's more or less that. And these all auto files are created by none other than the auth module, right? So yeah, my first ever Perl module was a Perl reimplementation of GNU Make. Can you believe that? Anyhow, I'm just going to show you what this looks like. So we have a little notice, right? So liver boilerplate. That's what I call these kinds of generated thing. And it has a like a precompile hook, right? So just it's something you declare in your setup file. You say I want this thing to run before compilation, and you just paste it in here as a begin block. We have post-compiled scripts. Right now I have nothing, and then it's just a long list of files, and that's that. And all of this is automatically generated, right? So you just call, you just make a couple calls to auth, and it gives all of this for you. And this one in particular is kind of interesting because it has all of these PMD files, and PMD files is basically just a list of dependencies, but for Perl modules. Yeah, it's you know, I could do without them, but I thought, what the hell, right? You know, if I update one module that depends on another, forgive me, if I modify one module and there's a bunch of modules that depend on those, I want those to be updated as well, because else you always have very weird bugs that you don't know where they're coming from, and it's because, you know, like things are not like updated properly, and that's always quite annoying. So yeah, okay, so let's just run that. And oh wait, I didn't show you the rest of the file. So it's this list of things, and then it's just like this thing, like it's always this. So it moves into the project folder, and it just set builds that, updates generated files, because this is a generated files manager. If you have any files within your source code that are generated files, Automat will handle that for you, right? So it will, you pass it the list of scripts and what they're supposed to generate, and it will do all the date checking and stuff for you. So it's kind of nice. And well, and then it will just you know, compile, you know, like actual compile for C, and, you know, quote unquote compile for Perl modules. So yeah, all right, that's that. Let's just run that, and if we get an error here, we know we messed up. Okay, so let's try it. And we do get an error. Okay, so I thought this was going to be boring. It is not. We have a bug, ladies and gentlemen. Okay, so 1255 in a DQ wrap. Okay. So this is and it's kind of interesting, right? Because this is just entirely divorced from what I was working on. So I have no idea what is going on. But likely, right. It doesn't like, it does, right. So read only does not like state. Okay, I get it. Oops. State. Right. I know it does take my, so let's do that. And actually, let me try the building again. And if we get the same error and the same file, yeah, it's actually because it's actually because something else is going on. Okay, all right. So it's not state. Where did I mess up? I did not use read-only. It's that, right? It is there. Okay. So it was not a bug, it was just forgetfulness. And it compiled fine. Okay. So, okay. Let me just check something real quick. I want to look into this. This is a little test script I'm working on. So, okay. Right. So what I'm gonna do is I'm gonna pass it this thing, and I'm gonna print out a couple branches. Okay. So for my branch in, actually, let me just call this branches, because that's kind of nice, you know. For my branch in branches, it's psychologically satisfying, no? Okay. Then we just preach this out, and basically this would give us like a couple of like an overview of some of like the first layer of the main scope of the PCC function within AuthPM, right? So we're going with a theme right here. Okay, so let's see. Okay, and this works, and so I would assume that I have not severely broken anything. Okay, because here's the thing: RD kind of just kind of needs that PLPS is functional and that AuthPM is functional in a sense, not entirely, but you know, there is a little bit of a synchrony between all the three. You know, to be exactly to be more exact, auth would depend on RD, but if RD was not functioning, auth could not perform certain functions that are essential to the setup of the project. And so if it compiles fine and it runs this little test script, then I know that nothing is too screwed up, right? So something might be screwed up somewhere, but not so bad that this test script cannot run. All right? Okay. So I want to look at these branch values, but first let's find branches width, okay? And how long have we been recording? Half an hour. I thought it was going to be another short video, but you know, every time I say this is going to be a short one, it is not. And it seems to me that the only mention of branches width is in Node. So that's, I already corrected that one. So let's just go check it anyhow. See, Node. Let's just go check it anyhow, because yeah, I can't really modify this one. Yeah. What you gonna do? Yeah. Okay, so that's a wrap, basically. That's a wrap. Okay, so nice. Let's look at these branches values. So it's the values across multiple branches. Let me just oops. Right, so it's branch values, right? So I thought something was up in the, okay. Okay, let's find dimensions. Okay, it's mostly from fundamental. Okay, so fundamental is it's a mechanism of the old parser, and yeah, I don't really care to fix it right now, but you know, just to play nice, let's do it. Okay. So I must have written this method solely to get some hack working in here. So yeah. It's a very short module, so okay, yeah. All right, so we are finding these, and because fundamental, we'll be looking. You know, it's like a helper for working with the output of PLPS programs, and so yeah, it will always be using these kinds of symbols. So actually, what we could try and do, I suppose we could make it so these regular expressions, which would be common across all PLPS programs, so basically um, general purpose parsers for basically any language, or at least C and Perl, right? At least any C-like languages that are similar enough to C that I can use this. You know, I guess I could do some Python parsing. Like, it's something I want to do actually, but I never get around to it because significant white space. Like, ah, so terrible. It's the worst design choice of all time. Significant white space. Mother of God. Oh, I shouldn't say that. That's actually heresy. Oh, never mind. Sorry. God is God is God has not been given birth to, okay? God is transcendental, alright. That's the truth, anyhow. So I'm just going to say, oh, actually I can do it as a state. Hmm. 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 I'm sorry, I'm just trying to think the best way to order this around. So yeah, I know that Mother of God is just an expression, like it's just a thing you say when it's just a thing you say. But yeah, I have some theological disagreements with that expression. Let's just say that. Let's just say that and leave it at that, okay? So the thing here is, we kind of have this. We kind of have here the same problem that we kind of have on the last on alt, right? So these are like very common, like very simple, very common titles, let's say. So values that could have that a branch could have, right? That a branch root could have, and so it would be a little bit hard to give it an appropriate name that wouldn't conflict with other patterns the that the parser would generally have to work with. So I think I'm gonna have to give them just slightly more complex names, okay? Okay. So give me a second here. I'm just rolling. Just having a little break. Okay, okay. Right, so perhaps what we should do is make a little hash out of this. And then we can use that hash in other modules. Why not? Fundamental is supposed not to rely on much. Just, I think, just node and, well, actually, let's check. I am rolling. Okay. So, yeah, it just implicitly depends on node. So, it's a soft dependency, right? So what's the trick? The trick is you pass in an instance of node, but you know, fundamental really doesn't need to know anything about node because I know something about node, right? So I know what the methods are named, and so I can just write that, and Perl will do everything else. Now, yeah, does this mean that it depends on node? Yes. Yes, node needs to be loaded in memory in order for this to work. But if you pass a tree, then node is in memory. So, and this would only be called in order to process the output of a PLPS program, right? So a pass tree, a PLPS pass tree, and you can only get that if you've already imported node. And so it basically it's implicit, that implicit dependency. I should, I could put it in here just to let you know that you need it. I don't see the harm in it, but yeah, I would have to list the library path and all of that. So yeah. I'm not gonna do it at this time, okay? So anyhow, let's actually I'm gonna call this ROM. It's gonna be my what should I call it? Branch re. Actually, I should put this in all caps. Branch re. Okay, and let's see if we can make this work. Okay, so read only my. I'm not entirely sure if it's gonna let me do it this way. Okay, we are going to try. All right. All right. This is not. No, I'm gonna have no. Wait. This is how. Okay. Right. So I didn't know, but I figured it out. Okay. So we just make a read-only hash. Right. Easy. And now we can just list the keys as such. I don't know why my mind went to, yeah, I have to make every item in the hash a read-only, but yeah, just make the whole hash read-only. Like, now you're thinking, right? Okay. So I'm just going to say name. And I can actually just copy and put them to the end of the file. Okay. Let's see. I need spec type name values. Okay. All right. Spec. Oh, I can't do that. Ooh, that's not nice. Okay. Give me a sec. Let's say balls. And this one will be highlighted, but it's inside a string, so doesn't matter. Well, It's not a regular expression, but you get the point. It being highlighted is just an error with the text editor. So, yeah. But the editor doesn't know better. I do. Okay. So now I can just say, oops, what was that? Spec. Okay. Branch tree spec. Okay. And now type. And we might not. Sorry, I'm just going to read. Okay. So I just my phone rang and I was like, "Who is it?" Right? It was a bot. So the cool thing here is that we would be saving quite a lot actually, because this thing would be called for every last frigging declaration. Okay, so this is like a loop within a loop. So yeah, nasty. For a small program, you wouldn't notice, but for something bigger than that, you would. So okay. $130. It should be at 40 by now. And beyond. Okay. So here I can already reuse that and directive singular. Okay. All right. And that's that basically. Okay. Let's just write this one. All right. Let's build. And that works. Okay. So let me just really quick just open up a file. Doesn't matter which one. Just to okay. Just to check that the syntax highlighting doesn't work, because this thing here that you see, rebuilding syntax files, that is actually how do you say? It's building the nano.rc files. Okay, so if we're going to config nano, what are you talking about? Okay, you see, I'm not generating all of these, but here the PLPS, the Python C, the JavaScript one, not this one, but this one, and the Perl and Peso. So, you know, languages you've never heard of, right? Peso and PLPS. So these are basically my languages. Yeah, I'm generating a syntax file for those because, you know, I have a list of keywords and syntax rules in order to have the parser work. And so I said, why not just use those in order to generate the syntax highlighting file for Nano? Why not? Actually, it started the other way around. Like this entire regex parsing madness, it began with this generating nano.rc files, because I couldn't stand the way that Nano was doing syntax highlighting. Like, it would just drive me out of my mind, the choice of colors and all of the bugs that it had. It still has quite a few, but I said, you know, I am a programmer. I should be able to do this kind of thing, right? It's just generating a list of regexes, of colors and regexes. It's not that difficult. And truth be told, it wasn't. So yeah, all of this is generated actually. So yeah, okay. That seems to be that. We have something working, and yeah, I basically just wanted to do this, okay? So let's see. Put. I'm not sure if this file was there before. I mean, I'm pretty sure it was because I use it as a scratch pad all the time. Okay, so how long? Okay, about an hour. Yeah, that's. You think that's enough coding for one day? I think yes. So, yeah. Okay, let's call it. So that's it for me, everybody. Uh, I hope you found this lesson in refactoring kind of interesting, and yeah, I'll keep on working. Bye.